Another common type of numerical series is called the geometric series. In this case, we have a starting number, call it a. The next term in the series is the prior term, but multiplied by a value r. So let's say we want to know the sum of n such terms. Why would we ever want to do this? Well, this series occurs quite often in engineering and finance. For example, you may want to know the total amount in a savings account where an amount A is deposited every year, earning an annual interest rate of R over a period of N years. But is there an easier way to calculate the final amount without having to actually calculate the interest each year and sum it up 1 year at a time? Well, of course there is, but it requires some ingenuity. Let's write out a representation for the geometric series as Sn is equal to a plus ar plus ar squared, etc., up to ar to the power of n minus 1 for n terms. Next, let's write the same equation below this one, but multiplied through by r. This gives r times Sn is equal to ar plus ar squared plus etc. up until ar to the power of n. Notice that most of the terms are exactly the same shared between the two series. Next, let's subtract the two equations from each other to get rsn minus Sn is equal to a times r to the power of n minus a, which we can rewrite as Sn times r minus 1 is equal to a times r to the power of n minus 1. Then finally, you can get Sn is equal to a times r to the power of n minus 1 divided by r minus 1. So now we have a much simpler expression for the sum of a geometric series. If we're given a, r, and n, we just need to plug those values in and we'll get a result that doesn't depend on summing each geometric term one at a time.